Okay, so I'm back for part two, and I feel this is the part that maybe you might need to see tonight or tomorrow night, because today most of you got through part one. So this is probably the most important part of the solution video to watch. So what we have here is you're told that the area region bounded by a parabola and horizontal line is given by the following equation. We want to find the area enclosed by y is greater than or equal to -2, and a parabola passes through those points. So here's what we do. We graph, just so we can visualize. And let's change colors so we can plot. So -2, -5, which is right here. 3, 0, which is right here. And 0, 3, which is right here. And of course, y greater than -2. It's kind of like that. So again, here are our points. And we want to find this area. I'll use a light green. Okay, I'm not the best shader, so I apologize. But that's what we want to find. We want to find that area right there. So, of course, what we need to know is we need to know the base. And the height. Well, it would be handy to know what the equation for a parabola is. So the first step, find equation for the parabola. And here's what we'll do. Remember, standard form is this, right? So if you have 0, 3, our equation will be 3 equals c. That was easy. If you have -2, -5, the equation will be -5 equals 4a minus 2b plus c, or -5 equals 4a minus 2b plus 3 because of that. So 4a minus 2b equals -8. And then lastly, we got 3, 0. So 0 will equal 9a plus 3b plus c, or 0 will equal 9a plus 3b plus 3, 9a plus 3b equals -3. So now you want to solve for a and b. You can use the Solve 2EQ program, or you can do it by hand. So I kind of ran out of space here, so I'm just going to use a program on my calculator right now. Let's see what the trusted calculator says. 4, -2, -8, 9, 3, -3. Nice. A is -1, and b equals 2. Let me make that a little bit cleaner. Huh. It does not want to erase. There we go. So the equation for a parabola is going to be y equals -x squared plus 2x plus 3. Which kind of makes sense from the drawing here. So now what you can do is to find the height in the y corner of the vertex. And that can be done by graphing this in your calculator. This will be very simple. So if I graph -x squared plus 2x plus 3, find the maximum, So I get 1 comma 4. So if that's at 1 comma 4, let's change colors up here. Let's go orange. And the height's going to equal 6, right? Because this is at -2, and the y-coordinate of the vertex at 4, so height's 6. For the base, you need POI, which stands for points of intersection. So -2 has to equal -x squared plus 2x plus 3. Or you can just use your graphic calculator. Graph -2 is your second equation in addition to the parabola, and have the calculator do the dirty work for you. So 1, 2, 3. So I'm using the little feature they have there for intersect. -1.45, and run it back. One, two, three. 3.45. So as the base is going to be 3.45 minus -1.45. Should be 4.9 roughly. Yep. So the area, which is what we want to find, got a little bit of space on the top right corner here. So A will equal 2/3 times 4.9 times the height, which is 6. Work it out. We get 19.6. Now here I said no decimal approximations. That's cruel. What you would do is you would actually use quad form down here in orange, where -2 equals -x squared plus 2x plus 3, and then have your radical answers, and then work it out. That's just super cruel. We'll say 19.6. That's fine. Okay, for number 2. We've done quadratic inequalities before. What you want to do is eventually use a sign chart. But first thing first, get everything on the same side. If we can factor this puppy, we will. Then you want to use a sign chart. Here's how a sign chart works. Put 0 in the middle, make a few tick marks. Find the zeros. Well, in this case, we only have 1 0, it's at -1/2. And it's non-inclusive, so I put a open circle. And then, in this case, there's only 2 regions, right? Less than -1/2. And greater than -1/2. So, if we test x equals -1, what we're going to have here is 2 times -1 plus 1 times 2 times -1 plus 1 to see if that is greater than 0. And in fact it is. Because you get -1 times -1, which is 1. 1 is greater than 0. Bingo. So I like it. That's good. If we test x equals 0, let's say, 2 times 0 plus 1, 2 times 0 plus 1, 1 times 1, bingo again. So I like that as well. Oh, it's kind of like Christmas, red and green. Sorry for round comment. Anyway, so everything works except for half. You can't plug in half. Sorry, I meant to say -1/2. Except for -1/2, you can't plug in -1/2 because then you get exactly 0, and remember, there's no equal sign here. So it's going to be all real numbers except for -1/2. Or you could say x is less than -1/2 or x is greater than -1/2. Let's look at number 3. In this case, write a quadratic equation in the form ax squared plus bx plus c equals 0 such that c equals 4 and the equation has 2 solutions. Well, let's start with x equals 2. If x equals 2, I'm going to have 4a plus 2b plus 4 equals 0. So 4a plus 2b equals negative 4. If x equals negative 3, I'm going to have 9a minus 3b plus 4 equals 0. Or 9a minus 3b equals negative 4 as well. And then you just solve for a and b, you know. Not too bad. See if I multiply this by 3, multiply that by 2. 12a plus 6b equals negative 12. 18a minus 6b equals negative 8. Add these two equations together, 30a equals negative 20. A equals negative 2/3. And then solve for b. Say use that equation. It should work out for us. You get negative 6. Negative 3b equals 2. B also equals negative 2/3. So your equation would be y equals negative 2/3 x squared minus 2/3 x plus 4. You can always check your answer. And sorry, I didn't even say y, because we have the solutions. We have to use 0 as the other side. My apologies. Yeah, because it had to be of that form. You can always check your work by quad forming it. So if I use my worthy quad form program in my calculator, and I'm not going to be a happy camper if this doesn't work out, because then I got to figure out what I did wrong. Sick. That totally works. So negative 3 and 2. Very, very nice. Okay, so number 4. Write a quadratic equation in intercept form if the vertex is 118 and pass through that point. Let's start with vertex form and plug in what we know. We know that x and y values are 0 and 16 respectively. We know h is 1 and k is 18. Work it out. A equals negative 2. So your equation is now this. Now, we're not out of the woods yet because you want the equation intercept form, which is this. So you have to actually FOIL and then factor. I like this problem because it kind of forces you to do a lot of different algebraic things. So it's really testing on a lot of different skills. So I FOIL the x minus 1 squared part. I distribute. I combine like terms. And I'll factor out negative 2. Oh, look at that. That's super cool. X minus 4 and x plus 2. So it came out very, very nice. So that's what you had to do for that problem. Okay. Lastly, number 5, then I need to get out of here so I can greet the trick-or-treaters in my house. Write quadratic equation integer coefficients that contain the following solutions. Yeah, this one's a little bit wicked here. But if 1/3 is a solution, right, it means you had this, or you had this. In all likelihood, you probably had x minus 3 equals 1 as an answer, and x minus 4 equals 3 as an answer. Or you probably had Wow. Okay, so someone needs a nap. Everything I did in the last 30 seconds, completely wiped away from memory. I meant to say 3x equals 1 is an answer, 4x equals 3. So if 1/3 and 3/4 are your solutions, x equals 1/3, x equals 3/4, then working backwards, 3x equals 1, or 4x equals 3, or 3x minus 1 equals 0, or 4x minus 3 equals 0. So that means that your quadratic equation was this. Foil it. And that'd be your equation. So it's just working backwards. That's all. And if you want to check, using the quad form program. So let's run this back. I'm about 99.9% sure this is going to work. Yep. That is awesome. So it worked. You feel comfortable with your answer. Everyone's happy. So that covers the solutions for the practice test. Be safe tonight with your trick-or-treating. And we'll talk about some great detail when I see you in class on Tuesday for B, F, or G period. Sorry, B, E, or F periods, and G period on Wednesday morning. Okay, good night.